with Brianna, Lori, and Kaylee for 10-16 for lesson 9. We've already gone over 1A, B, and C, and D, but my computer shut down, so we lost that. But we are now on number 2, and we have said that A is the population is of the realtor's clients who have purchased an investment property, and then the null hypothesis is 47 equals mu, whereas the alternative equals 47 is not equal to mu. Okay, sorry. Also, B is stratified. Holy crap. Stratified sampling. Okay. C, Brianna.
Okay, describe the data, graph the data on a histogram, sketch it or paste it. Short paragraph, describe the data by using at least 5 descriptive statistics. So, I'm guessing we just have to plug it in, right? Plug the numbers in.
Mm-hmm.
Yeah, I go to VMware. Crap.
Okay. I'm gonna start a new leaf here. Return.
That was a cool sound.
Okay.
Here we go. And it would be that one.
Okay, so we need to make a histogram.
Oh wait, it's I was thinking, oh, what process or what thing do I need to get on, and then it's like, what program is? Oh, IBM SPSS. There we go.
Mm-hmm.
Okay, I'm gonna run to the bathroom really quick while this is loading. Okay. Sorry, guys.
Sounds good. We'll time you. Just kidding. Don't go scuba diving. Okay. What is the population? Oh wait, that's the wrong one. Okay. Copy. And paste.
So do you do your work on your computer?
I do.
Okay.
Yeah. I'm a lot faster typer than I am a writer, and I'm a lot neat. And I can never read my handwriting, so it's just wasting my time. So.
Well, I was just wondering.
Yeah. It's convenient too. I do it on Google Docs because I don't actually have like Word. So, and it makes it nice because I always it saves me from losing my work, which happens to me a lot for some reason. So.
Yeah, you gotta save your work.
I forget to do it. Always bites me in the butt.
Oh, that hurts.
Yeah. Okay. Now, so I guess we can wait for Kaylee. So we're just doing the same descriptives as we did last time?
So this is the one that you said you could just find that it was probably already in there?
Mm-hmm. Yep. Oh, Actually, this is what I did. I just copied and pasted it from
Oh,
the,
numbers.
yeah. So I didn't look for it. I figured they'd have a link, so.
Because yesterday it wouldn't work when we did it on here.
Oh, really? Hopefully it does today.
Yeah. Does it matter what order you put it in?
I don't really think so, because it's not doing... No, I don't think so. I just put it in the order that it came.
Okay. Sorry, guys. That took me a second.
D5.
I'm gonna go back to this. Okay, so you're just doing 7, 49 tab, 6 tab, 45 tab, 49 tab, tab, 46, tab, 48 tab, 38, tab, 58 tab, 51 tab, 6 tab. Okay, so from there, let's see. We have to do a histogram, right?
Yes.
So graphs, legacy, histogram, variance 1. Yes, variable. Okay. Let's do it and do it and do it and copy it and paste and paste and paste. Okay. And then, so guys, I figured out why I was not able to see the 5 descriptive statistics.
Oh, really? Why is that?
Yeah. Well, or like the 5 number summary is because I didn't have certain things marked out when I first like got on to or how do you say? Like you have to literally go into the frequency section of statistics. So you go analyze this descriptive statistics frequencies, and then after you put the variable in the variable box, you have to hit statistics and then like choose what things you want to know.
Oh, how funny.
Yeah, I was like, well, dang, that's interesting.
I remember that, but you just reminded me of it.
Yeah,
That's
I didn't even know. I was like, dang it.
I wonder if I'm doing it wrong this time then. Let me try something else.
No, you're probably good. You're pretty good at it. Who knows?
Frequencies.
And then I want to write right here. Let's see. Equals 7 equals 8, 2, 3, 6, 9, plus 46 minutes. 3, 3, 3. And then that's one standard deviation equals. Okay. So did you guys get that all up? Sorry.
Yep.
Okay. Yeah, you guys probably got it up way before me. Okay, so we got the histogram, and then we picked 5 different summaries, 5 descriptive summaries. So what do we determine from that sample? Is the hypothesis, the null hypothesis correct, or the alternative hypothesis correct?
Let's see. Can we do that yet, or do we have to wait until part D?
I think you're right. I didn't even realize that the I, triple I.
Yeah, it's a lot of them.
So, yeah. Oh, whose turn is it for I? Who wants to do that?
Wait, so what do we, oh, in a short paragraph, describe the data. Okay, never mind. So, whoever's turn it is.
I don't
I
know.
can't
I'll go. Check the
Okay.
requirements. Since there's only 15 pieces of data, what would you need to check?
Okay. You
You
need
would
to check the normal distribution, right? I don't know.
Well, that would make sense. Like, is it a large enough? Is it a large enough group that there would be normal distribution?
Yeah,
It looks like it's
I
more
don't know.
left. It's more skewed.
Mhm. Yeah.
check a QQ plot.
Oh,
Uh-huh.
that's a really good idea.
Yeah.
Holy timing. Let's do it. Do it. Do it. Let's see.
Okay, we'll do that then. Analyze. QQ plot. Oh. It looks pretty normal to me.
Okay.
Considerably.
Yeah, I mean it's along the line. There's slight. It's a little bit off at the top and then also in the center, but I
Yeah.
don't know. What do you think, Lori?
Oh, I don't have it up right now, but if it's pretty much on the line, then it would be an accurate sample.
Yeah.
Oh. Okay.
Well, it's okay. They don't even ask it, so we'll just. Okay. Is it your turn, Haley, or is it my turn?
Yeah, I'll do it.
Okay.
I'll do it. Okay. So, state the null and alternative hypothesis. Is this a one or two-tailed test? So, I already did this, but
I think it's a two-tailed.
I
I think
agree.
you're right. 47 not equal. Yeah. Okay. Two. Because it's either not equal or equal to. Yeah.
Mhm.
And then, Brandon, do you want to take 3 or triple
I
I?
would like to. Just a second. And 2, 2. Okay. So let alpha be 0.05. Okay. Awesome. I guess we would find what does that mean again?
Alpha.
Wait.
It's basically how our test scores will, how our data will be compared.
Okay. So I guess is that just a statement?
I think so.
Sorry, I'm confused.
Doesn't look like you really do anything with it until the next question.
That's what I'm. So, but if
Okay.
it's that, then is it like are you supposed to say, oh, if it's that, then we accept or reject the hypothesis?
Yeah, exactly.
Yes, that's what it's for.
Okay. You want me to read the next one then?
Wait, so did we have an answer on it? Sorry.
We can't do that until we get the next one. So.
Ah, okay.
Yeah.
Let's do the next one.
Like we're setting up the the problem.
That's our thinking process. Yeah.
Oh, I get it. Okay. Okay. Was that the next one? Whose is the next one? I don't even.
Compute the test statistic. What is the formula to be used? Recall our test statistic will be z-score. After writing down the general formula, input the numbers you will use. Show this work. Finally, use Excel or a calculator to compute your test statistics. Z equals X bar minus mu over sigma divided by the square root of n, and the numbers are 46.733 minus 47 over 5 divided by square root of 15. Is that correct?
Yes.
I'm getting there. My calculator is not turning.
So the mean was 46.733. Okay.
Yeah. And then divide it by. Okay, look at the standard deviation. You said the standard deviation is 5, right?
Yes.
5. There we go. 5. Square root of 15. So it is. So did you guys get negative 0.2068? It would be like 207.
I got, no, I didn't. But that doesn't mean I'm right. I got 0.209. I don't know if that's right.
I'll be there in just a second.
Yeah, I'm wondering if I divided by.
I got negative 2.06817 da 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 da.
I got 2.7 as well.
Negative 2.7.
Well, I'm confused though. So I've taken a look at the answer key at this point, and it does say that the answer is 0.2091. So Lori, how did you get your answer?
I thought we just took the 46.733 minus 47. You get that answer, and then you get the square root of 15. 15 square root.
So, and it would be 5 divided by the square root of 15, right?
Right.
Mm-hmm.
Yeah. So that's exactly what I have on my calculator right now, and I'm just like, okay, so what am I messing up right now?
I'm gonna try breaking it down.
The square root I got as, well, if you round it up, it's 3.873.
Okay, let me write this down. 873. Okay. And then
46.733 divided by, no, minus.
Now I have something totally different. Okay. Oh, interesting.
But it is 46.733 minus 47, right? So it's like divided by 0.2909. Oh. No.
I bet you the difference is just that they rounded it
So
before
then,
they plugged it in.
I'm still getting the same thing.
Okay. And so,
Points.
divided by 3.873 equals 1.
267 divided by 1. 9.
What? Did it stick? Should be fine though.
Okay, I still have the same answer.
That's what I got. I got negative 2.2068.
That's what I got.
Well, I think we're right, guys. I say we're
Okay.
right. But okay. Then it says to next compute the p-value. So first sketch a normal curve graph here. Okay. So now, oh, I need to get the normal probability output. Hold on, let me do that.
Okay.
Sorry, guys.
It's okay.
I'm sorry. I'm sorry.
Ooh. Hmm. What the-
Okay, so it's 206. So for this, guys, would we shade, after inputting the p-value, would we shade the center?
What's that?
So after putting in the p-value and the normal probability applet,
Mm-hmm.
would we shade the center or shade like the center and a side or?
You
I
shade
thought it was the outside.
yeah,
Okay.
the two tail ends. Yeah.
Okay. Then just based on that area, the p-value will be like the area, which is 0.8360.
Uh-huh.
Yes. Okay.
Okay, so we compare it to the level of significance next. So we would fail to reject the null hypothesis.
Yeah, because it wasn't
Not.
the right amount, right?
Yeah.
Right.
Okay. So
There's insignificant evidence that the mean is the age of the people buying the second home.
Mm-hmm.
Different in the area than the national, in this area than the national average.
Mm-hmm.
And then it says take action. What action, if any, do you suggest the realtor take based on your statistical conclusions? Working with middle-aged for a second.
yeah, like help people who are middle-aged, because it's probably because they're better financially stable because they're not doing school and they're not doing other things.
They've already bought their first home.
Yeah.
Okay.
That makes perfect sense. Or it's like, I know from experience, y'all.
I gotta know something, being old. So you got 8.8360 for your area?
Yeah, 0.8360. Yeah.
Okay.
Okay.
Is that it?
All right, guys. Are you ready to take a group quiz?
That's right.
And I need to mark that I already got the homework done. Whoops. That's embarrassing. Okay. I was like looking at it and I was like, oh, I need to do something. Oh, crap. So it's good. Okay. So do you guys want to start? Because I'm starting.
Yeah, let's do it.
Okay. Okay.
Start.
Okay.
Status quo.
Yeah, status quo 1. That's the null hypothesis, right?
Yeah, that's null.
And then 4, which hypothesis involves equality? Isn't it the null hypothesis?
It's the null hypothesis too.
Okay. And then, Brianna, do you want to take number 5?
Sure. The p-value is the probability of obtaining a statistic at least as extreme as the one that was actually observed. Alright, when computing this probability, which hypothesis do you assume to be true? Hey, look at that. It's the null again.
Like, one of these is null.
Tricky.
Okay, now we're getting to the sticky part.
Oh, yeah.
All right, Laura, you want to take number 6?
Suppose the null hypothesis is H0 colon mu equals 10. Use this information to answer questions 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test?
The
Mu
third
does
one.
not equal 10.
Mm-hmm.
Yes. Okay. And then number 7, which of the following represents the alternative hypothesis for a left-tailed test? Now, that would mean that mu is greater than 10, right?
I put u as less than 10.
It's less
Just because,
Okay.
yeah,
go
that's
with you.
because when I was reading it, I remember like putting it and says if the little tail of it is facing the u, then it's. But I could be wrong. That's just what I remember.
No, I think you're right, because when I was just like, when I was looking over it, I was like, I think it's like if the mean is greater, yeah, let's go with what you said though.
Okay, if I'm wrong, I apologize.
Because my theories are crazy. Okay. And then, Brianna, you want to do number 8?
Which of the following represents the alternative hypothesis for a right-tailed test? Let's hope that we're doing this right, because if one's wrong, the other one's wrong.
Tails.
Okay. So then it's the other one. Okay. Then, Lori, do you want to do number 9?
Number 9. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis?
Failing to reject the null hypothesis.
So it would be that the p-value is, it's that it would be, it'd have to be, well, because like the value of it would have to be greater than the level of significance, right?
Oh, is that little chart with the?
The p-value is in the area of the probability applet.
I thought it was like the truth and decision little chart
The truth and
on, it's like
Okay, hold
on the page with question 12 and 13.
Oh, I don't know.
I don't, because on the chart, what the chart was using it for was to determine the type 1 or type 2 errors. So
Oh, this
I think
that's right. Okay.
yeah. This,
Hold on, guys.
Oh, that is confusing.
so failing to reject it means that the p-value is not less than alpha, meaning that if we fail to reject it, the p-value would have to be greater than alpha. I think that's what I understand, at least.
So, and guys, something I realized this last week, that if we have a question and we need to find it, we can save the quiz for later, and we can go over this.
Oh, awesome. Okay,
So if we're really confused about something, we can do that.
that's good to know.
But
Okay.
So then, okay, so for number 9 though, and for number 10, right?
Mm-hmm.
So
Yes.
for failing to reject the null hypothesis, would it be the second one? The second? It's like the p-value is less than the level of significance?
No, because alpha, like let's say that we had a limit, a level of significance of 0.05. If it were above 0.05, we would fail to reject the null hypothesis. But if it was less than 0.5, we would assume that there was sufficient evidence for the alternative to be true.
So wait, but which one of it is it? Like,
The
is what I'm
p-value
trying to
is
make sure.
the first one. P-value is greater than A would mean we're failing to reject it.
Okay, and then the one that says p-value is less than the
Rejecting it.
alpha would be rejecting.
Mm-hmm.
Okay, that makes sense. Okay.
If
And
the value is
then
less than A, we reject the null.
Mm-hmm. Yep.
That's on the last page with our references.
Okay. Perfect then.
okay. This is good that we're figuring this out. Okay, I will read number 11 if that's okay. An insurance company's current policy rates. When originally setting the rates, they believed that the average claim amount was 1,500. They're concerned that the true mean is actually higher than this. Use this information for question 11 through 12. 11. Which of the following would be appropriate alternative hypothesis? It would be that the average claim amount is greater than 1,500. Would be the alternative.
Mm-hmm.
And then number 12, Brianna.
Which of the following would be the appropriate null hypothesis? And that's always equal. So the first one. Equal to.
Okay. And then, Laura, do you want to do number 13?
The insurance company randomly selects N equals 40 claims and calculates a sample mean of X mean equals 1,650. This uses information for questions 13 through 15. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? I would say yes, because N is 40.
Yes.
And then number 14, what were you about to say, Brianna?
I was just saying which relates into the next one.
Yeah. And it says, what theorem or law justifies your answer to the previous question?
Central limit
theorem. Right?
So,
yes.
Yeah, that's right. I'm just tired,
Okay.
sorry.
Oh no, I'm exhausted too. Let's do this. Woo!
Okay.
And then Brianna, 15.
Which of the following is the test statistic as defined in this lesson? And that's kind of a tough one. Wouldn't it be Z?
Would it be?
Or would it be X bar?
I kind of thought X bar at first.
That's what I thought at first. But I don't know. What do you think, Lori?
I do not know.
Because I know that the test statistic is whenever you find the Z-score, and then, isn't that right? Or am I wrong?
Yeah, no.
Z-score a lot on this kind of stuff. We've been looking for the Z-score.
Yeah.
Yeah, I would assume that the Z. Just looking at the 4.2 test statistics, it says that, yeah.
Okay.
That would.
Okay, I guess we'll find out the hard way.
That We'll find it out. We'll get it.
Yeah.
All right. And Lori, is it your turn? Sorry.
The historical mean of sales receipts at the grocery store is 150 with a standard deviation of $40. The store manager suspects that average has decreased. She sets up a hypothesis test with the following hypothesis. The null is the mean equals 150, and the alternative is the mu is less than 150. She will use the level of significance of alpha equals 0.05. Then she takes a simple random sample of 36 sales receipts from her store and computes x equal, or the mean equals 144. Use this information for questions 16 through 18. What's the z-score?
We know how to do this one.
All right. 150. All right.
The 150 is the mean, right? No.
Yes.
So that's the mu.
Mm-hmm.
And 144. 144 minus 150 over 40.
40. Is it divided by square root of 36 too? Because she takes a random sample of 36 sales receipts.
That's probably right. -6 over 36 divided by 40 divided by 36.
So guys, let me know when you have the z-score.
Okay. Okay, I've got it, I think.
Six.
Hope I got it right. Should by now.
So did you get a negative z-score?
Yes.
Yeah.
-8,999.
Okay. Yeah,
I got -0.9 is what my calculator rounded it to.
Yeah, mine too. So, sounds about right. Because you got 8.99.
Yeah.
Alright, now we'll plug it in for the next one, number 17. Was this a two-tailed one, or is it one-tailed? It was two-tailed, wasn't it? I was just asking if,
No, this is a one-tailed.
this is one-tailed? Okay. Oh yeah, you're right. And we go to the left, right?
That I don't.
Let's see, because if the average claim is greater than that amount, then yeah, it would be, because they're trying to prove whether or not it's true that a claim is greater than
Mm-hmm.
that amount. That would be the -0.9, the middle, and the side. So it'd be like 0.8159, maybe?
I think you just do the tail. I don't think you do anything with the middle.
Oh, okay.
Yeah.
So would it be the tail on the left or on the right?
On the left. I'm pretty sure that's what I read.
Did you get 0.3681 for the? Oh, it's just on one side.
Oh, okay. Yeah, I got 0.1841, but you gotta round to 3 decimals, so just 0.184 is what I got. But
Okay, then I'll have so we put 0.05.
you put -0.9 into the z-score area.
Okay.
But then on number 17, did we get 0.84? 0.184, sorry.
Yes.
Yes.
Okay. And then, okay. So then, number 18, what inference would you make about the null hypothesis for this problem?
We would fail to reject it, I think.
We would what?
Wouldn't we fail to reject it?
0.184 is higher than 0.05.
And whenever it's higher, isn't it when we fail to reject it? And whenever it's significantly lower, we reject it?
P-value is less than alpha, we reject the null. So p-value is higher, then we fail to reject. Yeah, you're right. There are 2 types of errors. Which one involves rejecting null hypothesis and null hypothesis?
Okay.
That is definitely the.
I'm kind of confused.
What's that, Kaylee?
Huh?
Did you say something?
Oh, I just said I'm kind of confused. So I'm like, okay. So based on like what we just said, the null, and the null is true, it's correct. So I'm like wondering for number 19, if like what type of error that can be made when performing a hypothesis test. Would it be type 2 because of if we failed to reject that null hypothesis, but it is false? Well, is that
Exactly. Yeah, type 2.
Oh, okay.
Okay.
All right, and then Brandon, did you want to do number 20?
Sure. A researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? Oh, okay. I remember this one. I put the probability of type 2 error would increase.
Okay. Yeah. And then, Lori, do you want to read number 21?
I'll read it. I don't understand how to do it, but if alpha equals 0.05, compute the probability of committing the type 1 error.
Oh, yeah, that's the same thing. So it would be 0.05, right?
Yeah.
Or 5%.
Yeah.
Yeah.
Okay.
Because just a way to remember this is just alpha deals with type 1, and beta, which they didn't really talk about, is just I watched it on the little video thing.
Okay.
Beta deals with type 2, so you can always just relate those two together.
Okay.
Okay. Yes. Okay. Are you ready to submit it?
Yeah,
Okay.
I hope.
When do you want to have a meeting for next week?
Guys.
Oh, that's weird.
You guys already submitted?
No.
Okay. Recheck number 19.
Okay.
Okay. But next week I am working on Monday, Tuesday, and Thursday, and I have Wednesday and Friday off. So
Okay.
if you guys want to do, we can either do Monday and Wednesday again like we usually do, or we can do Wednesday and Friday. What works best for y'all?
Wednesday and Friday will work.
Yeah, Wednesday and Friday will be good.
Alright, I'll make sure to send Hannah an email. Just let her know.
Okay.
So let's plan on, does 5 Mountain Standard Time work still?
Yeah.
Yes. So 4 o'clock Pacific.
Yep, and then like 7 o'clock your time, Brianna.
Yeah. Sounds good to me. The more time, the better, I guess.
Yeah. Alright, well, good job,
You live
guys.
in Texas or something?
I live in South Carolina, actually.
Oh, wow.
Yeah, I'm way out there.
Yep.
This
Son
is
want to
fun.
visit South Carolina.
Oh, what was that?
Oh, my son and his wife are going to go visit South Carolina
Oh,
next.
well, they should. I'm biased, but it's awesome.
Alright. Well, I'll get this posted.
Sounds good.
Okay.
Good job this week, guys. You're
Thanks.
All right,
awesome.
thanks. Thanks, guys. Talk to you later.
Bye.
Bye.
Bye.